Looking at the face of the coil, normal to its cross-section from the front, if the current in it appears anti-clockwise, then that end of the coil behaves as a north pole and the other behaves like the south pole. But if the current in it appears clockwise, then that end behaves like the south pole and the other end like the north pole. Suppose a bar magnet with its north pole pointing towards the coil. The current in the coil flows in such a direction that the face of the coil towards the magnet behaves as a south pole. If this assumption is correct, then by moving the magnet only slightly, its north pole is attracted towards the coil and the speed of the magnet increases continuously. Hence the current in the coil increases and it attracts the north pole of the bar magnet more strongly. In this way, without doing almost any mechanical work, the accelerated motion of the magnet can be maintained, and without spending any energy, heat energy equal to I square RT can be obtained from the resistance connected in the circuit of the coil. But according to the law of conservation of energy, energy cannot be produced without spending some other energy. Hence our assumption turns out to be wrong. Hence, when the north pole of the magnet is moved towards the coil's face towards the approaching magnet must behave as the north pole, and the EMF and the electric current must behave in the required direction for this. If it happens like this, the mechanical work would have to be done to continue the motion of the magnet towards the coil. If it happens like this, the mechanical work would have to be done to continue the motion of the magnet towards the coil. At the cost of this mechanical work, heat energy is produced in the resistance in the coil circuit. This discussion shows that the induced EMF and hence the induced electric current is produced only in such a direction that it opposes the very cause, here the motion of the magnet, which produces it. This statement is called the Lenz's law.